Hello everyone and welcome to the showcasing of the Tic Tac Toe GUI, where players can play against an implemented AI that plays the game optimally using the MiniMax algorithm. So this program uses two files, the runner.py, which handles the graphical interface aspect of the program, and tic-tac-toe.py, which handles the game logic and implements the AI. So if we look at our tic-tac-toe.py real quickly here, we'll see that we first defined all of the pieces that we can play, and then we have a function that initializes the state. So our visual board will be thought of as an array containing three arrays, each representing the row in the tic-tac-toe respectively. And then the function that determines whose turn is it based on how many X's and O's have been played, a function that takes in a board state and outputs a set of all of the possible actions to be taken by that player, and then a result which takes in an action and a board state and outputs or returns an array that's a deep copy of the board state so as not to alter the original board, which would contain the outputting the result of making an action in a given state. And it's worth mentioning here that the actions is just a tuple represented with two numbers, the former standing for the row, the index value of the row, and the latter standing for its position in the array. So saying 0, 1 will be the spot. And then our winner function, which determines or returns the winner if one exists, a terminal board, a terminal which takes in the board state and determines whether the game is over or not, and the utility function, which is used by our algorithm to give a value to each given board state. And then our minimax algorithm, which has a max value used by the X player to pick the best solution or the best action possible, maximizing the score, and the mini value, which attempts to minimize the score. So if you run our game here, let's play as the X player, and let's say I play like so. And so if I play X here, you would expect the O player to win the game by playing in this spot, correct? But if I play it here, it will do its move here, where either way it will win the game, but it did take longer. And I could improve the performance of my program by implementing a way for it to see the depth of each move and then pick the move that will finish faster. But the downside of this, that even if it found a move that's guaranteed to win, like just now, it will still have to wait and evaluate all of the other actions in order to determine one that's shorter, which would make the calculating process shorter. So instead, I've decided to implement an alpha beta pruning, where if it finds the best move, which is the move that will guarantee its victory, it will just return it without evaluating the other moves. And if I play as O here, you'll see that the game is thinking. If I take center and locked, and I don't think it matters here. Oh wait, my bad. And now yeah, the X wins. And that's pretty much it for my AI. Thank you so much for watching and have a nice day.